Hey everybody, it's Ben and welcome back to another Leetcode video. And today we're going to be looking at problem 2414 called length of the longest alphabetic continuous substring. So we'll read through the prompt, we'll walk through the pseudocode, we'll walk through an example, and then we'll code up a solution. I'm going to go ahead and remove this for now. So an alphabetic continuous string is a string consisting of consecutive letters in the alphabet. In other words, it is any substring of the string of the alphabet, A, B, C, D, so on and so forth. For example, ABC is an alphabetic continuous string, while ACB and ZA are not. So given a string S consisting of lowercase letters only, return the length of the longest alphabetical continuous substring. So let's go ahead and talk about the pseudocode here. So the problem here is simple. We need to return the length of the longest alphabetical continuous string present in the given string S. This will be a substring of the string of the alphabet, as shown right here. Now note, a single character does count as a continuous string of length 1. My initial thought for this problem was to generate substrings of the above alphabetic string and run the contains command to see if the substring is present S. This maybe could be doable, but it's actually pretty time consuming and more difficult than this problem needs to be. So this can be done in a one-pass method, which is a pretty easy manner. So we can use ASCII values, or American Standard Code for Information Interchange values, to make this a lot easier. So lowercase letters run from values A equals 97, B equals 98, to Z equals 122. As you can see on this table right here on the right side, you have 98 through 122 are your lowercase integer values in the ASCII table. So getting back into that document, we need to check that, well, obviously each character has a value of 1 greater than the previous character in alphabetic order, speaking for lowercase characters. So to get the ASCII value of a character, we simply need to cast them to an integer with the int statement in front of a character. Thus, I can use a counter variable. I can loop through each character in string S. If the current character's ASCII value plus 1 equals the next character's value, I know that they are in alphabetic order, and I can iterate my counter. Else, I'll reset my counter to 1, because a single character has a length of 1 and is technically in alphabetic order. Now after each iteration, I'll update my global max value, and I'll return this once my loop terminates. So let's go ahead and look through the pseudocode here. First, we'll initialize our int variables max to 1, I to 0, and C to 1. Now while I is less than string S length minus 1. So this is because our if statement will ask for the character at I plus 1 each iteration. So to stay within bounds, we need to subtract 1 from our parameter. So if, notice the int statement here, the character at I plus 1. So we're getting this value first, then we're adding 1. Equals int character at I plus 1. We'll iterate C. Else, we'll set C to 1, because a single character is always in order. Then we'll set our max equal to the greater of max in C. So we'll update this each iteration, and then we'll iterate I. And we end our while loop and return max. Let's go ahead and look at an example here. We'll say string S equals ABA, CABA. We'll set max to 1, I to 0, C to 1. Now while I is less than S.length minus 1, so for I equals 0, we use our if statement here. If int S.character at I plus 1, so this is getting added after this value is found, equals int S.character at I plus 1. So that would be A plus 1 equals B, or 97 plus 1 equals 98. That's true. So we can iterate C, and now C equals 2. Update our global max. The max of 1 and 2, which is max in C, is going to equal 2. So max equals 2, and iterate I to 1. So now while I equals 1, our if statement here, we're saying B plus 1 equals A. Is that true? 98 plus 1 equals 97. That is false. So our else statement will catch, and we'll set C to 1, iterate I to 2. When I equals 2, if statement here, A plus 1 equals C, 97 plus 1 equals 99, that's false. So our else statement catches, c equals 1, iterate I, and again, each iteration we are testing for our max, but it's not going to catch, so I didn't throw it in. Now when I equals 3, if statement, c plus 1 equals a, 99 plus 1 equals 97, that's false, c equals 1, iterate I to 4. When I equals 4, if statement, a plus 1 equals b, that is true, iterate c to 2. Our max is going to remain 2, because max is already 2, c is 2, so it just stays 2. And I plus plus, so I equals 5. Now when I equals 5, we go ahead and test, b plus 1 equals a, 98 plus 1 equals 97 is false. Go ahead and set c to 1, iterate I to 6, and at that point our while loop breaks because I is greater than our parameter. Then we return our max of 2. Let's go ahead and code up a solution. So first we'll say int max equals 1, we'll say int c, which is our counter, equals 1, we'll say int I equals 0. While I is less than s.length minus 1, I'll say if int s.character at I plus 1. So notice how it's outside of the parentheses of the I equals int s.character at I plus 1. Then I can iterate my counter. Else, I will set c to 1. I will, every iteration, test my max c, and then I'll iterate I. Now our while loop will break after that, and we'll return our max. So let's go ahead and run the solution. As you can see, that's going to work. We'll go ahead and submit it. And that should get you, it should get you faster than that. I'm not sure why that one ran so much slower than my previous submissions. It should get you around the 17 millisecond mark, which would be about 80% faster. Memory is going to be pretty consistent at this level, so we'll say about 50% faster, or 50% less memory. But overall, this was a fun problem to test the kind of your logic, thinking through ASCII values of characters and how useful those can be when manipulating strings and characters. So keep that in mind for future problems. But thank you very much for watching. Hope you learned something, and have a great day.